normal numbers, right, using the long division method. But do you know how to divide algebraic expression by another algebraic expression, or a polynomial by a polynomial, such as x square plus 3x plus 2 divided by x plus 1? Let's try how to do that. One method is you write the dividend as the numerator, x square plus 3x plus 2, and the divisor in the denominator. Then you can factor out the numerator using the middle term factorization method, and you get x plus 2, x plus 1 divided by x plus 1. Here x plus 1 gets cancelled, and we get the answer x plus 2. But we need to make sure that x should not be equal to minus 1 here. Otherwise, the denominator will equal to 0 and the whole term will go to infinity. So this was pretty simple, right? But what if the numerator cannot be factored out so easily? For example, if I change the value of the term containing the power of x as 0 to 3 over here, x square plus 3x, and instead of 2 let's make it 3. Now this will not be so easily factored out as the above term. And if I ask you to divide this by x plus 1, so there must be another way to perform this division, right? Yeah, there is. The long division method. The way we used to perform long division for numbers, it is almost the same for polynomials as well. Let me explain you how to do it. Here we put the dividend in the big bracket and the divisor out. Now, how to divide it? We first take the term with the highest degree in the term with the highest degree inside the bracket, and the term with the highest degree of x outside the bracket, and we divide those two terms. So x square by x will give you x, right? Because x times x is x square. Now, after dividing the leading terms or the highest degree terms, we get x, we put the value over here, right? Now, we multiply this term with the whole divisor. This is called the divisor, the term with which you divide this term. Okay. Multiplying x by x plus 1, we get x square plus x. Now we have to place the terms with the same degree of or the same power of x below each term. So x times x is x square. So we put x square below the x square term in the dividend. So here we put x square, and x times 1 is x. So we put it below the term which has the same power of x. Over here it is 3. Now what do? We subtract both the terms. These two terms and these two terms we subtract it. We get 0 here and we get 2x here. The next step is to now divide this remainder with the divisor after bringing this additional term down. Okay, so we bring this 3 down. It is very similar to the way we used to do the normal long division, right? We used to bring the additional term down and then we divide the divisor again with the remainder. So it's the same over here. Just that we need to find out the leading terms, the terms with the highest degrees in both the divisor and the dividend, and we first divide the leading terms. Now what is the leading term in the numerator and in the dividend and the divisor here? It is x, 2x here, and this is x. So dividing 2x by x, we get 2. So we put 2 over here, 2, and we multiply 2 with the whole divisor again. 2 times x is 2x, and 2 times 1 is 2. We subtract again, we get 0 here. Subtracting 2 from 3, we get 1. Okay. Now can we further divide 1 with x plus 1? No, you can't, right? The highest degree term over here is 1 and here it is x. How can you divide 1 by x. Can you divide it? What multiplied by x will give you 1? Nothing. So you let this be as it is. So the same way we let this be as it is, and this will be called our remainder. And the way we represent our remainder is we put the remainder in the numerator and the divisor with which we had to divide it in the denominator. So this fraction represents our remainder. Okay. So how do we present the value of this division? We add the quotient, which is this quotient, and the remainder. So quotient plus remainder, we get x plus 2 plus 1 upon the term which we had, the divisor, x plus 1. So this is the value of the division of x square plus 3x plus 3 by x plus 1. This is the value. This is the answer. Now if you want to verify or you want to see how this is related to the factorizing method, we can perform one exercise over here. If I add both of these terms, what do I get? X plus 1. Okay, here you get x plus 1, x plus 2 times x plus 1, right? When you add, this will be multiplied with the common numerator, and then you add plus 1. When I add this, I got this term. Now again, if I separate the two separate terms of the numerator, what will I get? I can separate this out by x by writing this in this way, right? X plus 2 times x plus 1 by x plus 1 plus the 1 by x plus 1. So what do I get? I got this fraction and this fraction. Now x plus 2 times x plus 1 and by x plus 1. Is this something which we have seen before? Right. This is the same term. This and this are equal. So this means that this term, which was x square plus 3x plus 2 by x plus 1, this is this term, x square plus 3x plus 2 by x plus 1. If you multiply these two, you get this one plus 1 by x plus 1. So this is nothing but this term splitted x square plus 3x plus 2, and the 3 here has got split in 2 and 1. So both the factorization and the method we used here bring us to the same answer, right? And they are very closely related.